Okay. Well, thank you. So as introduced, I'm Daniel Mekonnen from TopQuadrant, and just briefly on myself. So at TopQuadrant, I'm a semantic solutions architect. I have just over 13 years working with the Semantic Web, and by virtue of working with the Semantic Web, that's my exposure to knowledge graphs. I've worked with knowledge graphs since before they were called that. Typical thing I do at TopQuadrant would be working with customers to take their legacy knowledge from databases, spreadsheets, and so on, and bring them into a knowledge graph representation, and then to integrate knowledge systems with their enterprise. So I'm here on behalf of Irene Polikoff, who wasn't able to be here today. She sends her regrets. Irene is more of our search expert. I am not, but I have lots of experience getting knowledge into and out of knowledge graphs, so that's something I can talk about. So this presentation, the questions I'll try to answer is what are knowledge graphs, and we think we sort of know that at this point. So I'll present a slightly different perspective, though in full agreement with what we just heard from Joe. And I found his perspective pretty interesting. A little bit on where they came from, so touching on the history, how knowledge graphs are different from property graphs, which are just regular graphs from graph stores. And the role of ontologies and taxonomies, which we've heard a little bit about as well. And then finally, just getting into, very briefly, how do you get the knowledge out of the knowledge graph? And with 20 minutes, we don't get into any topic too deep, so this is just enough to hopefully pique your interest and have you want to learn more later. So getting into the first question, what are knowledge graphs? So this is our take. Well, knowledge graphs, considering what are knowledge graphs, opens the door to the question, well, what is knowledge? For which there's not a lot of agreement, philosophically or biologically, what exactly knowledge is something people debate. There's a lot less disagreement on what knowledge graphs are. But our take, very simply put, is knowledge graphs are a collection of facts about some domain of interest like pharmacology, biology, it could be banking law, physical systems, and so on. But not just the facts, but the rules that govern how you can use those facts to give scope to the validity of that knowledge or to help you derive new knowledge based on what you know. So our goal with knowledge graphs is to largely store the knowledge and the facts that govern them, but in such a way that's easy to retrieve the knowledge, to manage and maintain that knowledge as it grows over time, as truth changes. Example of a truth changing was the email I had for this conference presentation was that it started at 3 p.m. I found out a couple hours before it was now 2 p.m. So truth has to be maintained. So getting into this knowledge graph or knowledge representation, the knowledge graphs come from the field of knowledge engineering, where after decades of research and experimentation, they arrived at graphs as being the most versatile structure for representing human knowledge in the way closely resembling how we conceptualize it or how we think about knowledge, where you have you have information connected arbitrarily as per the relationships in this unconstrained structure called a graph. This is in contrast to working with relational databases where you're confined to working with rows and columns, which is maybe not so close to how we think about things, or not always. Graphs come from the field of mathematics, so there is this logical, mathematical underpinnings to them that make them really conducive to working with information systems. They can work with this structure very efficiently. We want to do more than just represent knowledge, though. We want to be able to process it, to put it to work, to take two pieces of information, two things we know, and conclude a third thing from it. We want to extract knowledge, to find knowledge based on what we know already, based on what we've stored. But we also want to be able to aggregate knowledge. We heard about that a little bit from Joe. So if I have a knowledge graph that I've developed in my department, and you have a knowledge graph you've developed in your department, I may want to integrate those together and do this across other units, business units, across our whole enterprise, maybe across the whole corporation around the world, and pull all this knowledge together into this super kind of mind to then work on more and more complex and broader problems. So this might sound pretty fantastic and far out, but it is attainable today, and this sort of stuff is going on already. And it's something you can do if you adhere to standards. And we have these standards in place already from the World Wide Web, from the World Wide Web Consortium, the W3C. This is a photo of its founder, Sir Tim Berners-Lee, and in his original vision for the web, he was thinking about knowledge graphs. This picture above him comes from his '89 paper, where he's depicted organizations, people, documents, and the complex relationships between all of these. So he was thinking in terms of knowledge graphs. Well, it took standards a bit more time to catch up to his original vision, but it's arrived. It's here. When you think about World Wide Web today, you're thinking probably of the media web, as I would call it. HTML files, PDFs, videos, audios, lots of advertising. But alongside this web of consumable media, we have what's called the Semantic Web. And the Semantic Web it's a collection of it's data that's linked together along with its metadata, giving us little knowledge graphs. We have interconnected knowledge graphs that coexist alongside the World Wide Web and served by all the same infrastructure, all the same systems. But this Semantic Web is really more meant for machines to consume than people, though people do at some point get exposed to it. And we saw examples from Joe with Google's sidebars. When you search for keywords, Google, since 2012, uses the Semantic Web info to show you a little knowledge graph in its sidebar. So these additional links coming off of your keyword for more information that you'd want to explore that it thinks is relevant. This is a knowledge graph, and I like Joe's explanation. That was in the instantiation of a knowledge graph, I think it was. I thought that was pretty cool. I was going to say flattened knowledge graph or laid out into to web form. But Google does use the Semantic Web here. They use dbpedia, and dbpedia in turn is the Semantic Web serialization of the Wikipedia. Some years on, Google was using knowledge graphs for its AI endeavors. Knowledge graphs have become a pretty hot topic this year. There's conferences and workshops that cover knowledge graphs in whole or in part. It's one of the leading trends. So much so that Forbes magazine has taken to covering knowledge graphs. So once a quarter, you'll find about that frequency articles from Kurt Gagel if you search for him. Okay, so distinguishing knowledge graphs from property graphs, and property graphs I would just call data graphs, in other words. Property graphs have just the facts. We see them in the bottom layer here, but we add to these facts models in the form of ontologies and then rules. And to illustrate what this is about, we'll use a very, very simple fact graph with three triples. Three pieces of knowledge here that James, this could be James Bond, has blue eyes. James' father is Andrew. And James is a person. This is all we know about James. At the model layer, and the model is still a graph, we define what a person is or what would be true about a person. So a person has eyes, eyes have eye color, a person has two parents, and a person's father is also a person with gender male. Rules would be, we have heredity rules, a very simple one, that if a person with blue eyes must have had parents with blue eyes. That's how heredity works. So given this information we have, these 3 bits of information, we can conclude that Andrew also has blue eyes. That's not stored in our knowledge graph, but we can conclude it based on the model and based on these rules we have in place. So then a search for all people with blue eyes would get back Andrew as well as James. And again, this isn't stored information. This is information we've deduced, or knowledge we've deduced based on what we know. And we're able to do that because we have the model and rules in place, Now with a regular graph, just a property graph that you get from a graph store vendor, you would get back in that search just the fact that James has blue eyes. You wouldn't get back that Andrew has blue eyes, because we don't have the smarts for how to work with that data. So that smart, that bit of logic and model information, if any, may be put into application code. That's the most common approach to handling that with regular property graphs. So we find having the models and the rules also as graphs is easier to work with, to maintain, to add to and manage later, and to reuse, importantly. We can reuse these models and rules with other graphs. Some more points on the distinctions between property graphs and knowledge graphs as we see them. And this is something you could read at your leisure if you downloaded the slides. The gist of it is that going with just simple property graphs, you're working yourself back into a silo, just a fancier new silo, a graph silo, because the property graphs do not have the same benefit of standards behind them. So every vendor that provides a graph store is going to do it in their own way. They'll provide their own query language. They may support one or two others. But property graphs at this point in time don't benefit from standards in the same way that the Semantic Web does. They don't have the W3C behind them. If you go with triple stores, and the triple stores will be RDF based, then you can work fully with knowledge graphs, with the models, with the rules, and if you don't like one vendor or one store, you simply move your data into another. You're not locked in. Okay, ontologies and taxonomies, depicting a little bit more of what we heard. So minimally, a knowledge graph from our point of view will have the data and the ontology. We always have an ontology. We may or may not have rules depending on the domain. This is a simple ontology for car manufacturers. So we have an organization that produces vehicles, maybe cars, trucks, motorcycles. Car is a subclass of a vehicle or a subcategory. Cars have makes and models. This is our ontology. It's schema-like, and it gives us a blueprint for our data. The data is where we get to specifics. So BMW is an organization. It produces cars of given makes and models. The ontology, of course, we could reuse for other companies like Ford, Toyota, and so on. In a knowledge graph, we have both of these things coexisting in the same space and interconnected. The data and the model are there in the graph and connected together. Pulling in taxonomies. So behind our taxonomies are, again, ontologies. Our rules of engagement with taxonomies, what they can do is defined through ontologies. We work with SCOS, is the most widely standard, I believe. It's a simple knowledge organization system. It's a W3C standard. From SCOS, we get the idea of a concept and a handful of relationships to connect concepts together. So the ontology we just saw, our example ontology, could all be derived from this concept notion, and that's what we would do. Make everything a subclass of concept. Our data then, we're still with the ontology, can be set up, can be reconnected as if it were a taxonomy. So where there is hierarchy within our knowledge, we can connect it through the SCOS ontology and produce that hierarchy we see on the right. So now there's BMW with other manufacturers, their makes and models. So with this taxonomy, we can employ it for faceted search, faceted navigation, for tagging, content tagging, auto classification, and so on, to drive websites. Getting the knowledge back out of the taxonomy, or the knowledge base, just very briefly. The language we work with more and more is GraphQL. GraphQL is a graph query language. It has its start at Facebook, where it was developed around the use cases for their social network. And GraphQL, we like it because it's fast. It's really lightning fast. It's great with large knowledge bases, knowledge graphs. It is limited in its expressivity. You are working with JSON. Queries are composed in JSON. Result sets come back in JSON. JSON's still a tree structure. But it's fast. It's for taxonomies, it's great. When you need more expressivity, then you have Sparkle. You can express very complex graph patterns. You think in terms of graph patterns when you work in Sparkle. It is a mature W3 standard, but the trade-off for the greater expressivity is going to be it's a little bit slower in most cases. But when you need it, it's there. So we support both, and these are whole topics unto their own. This is the sort of thing we do training around. Okay, well, jumping to conclusions then. Property graphs, the takeaway is it's just the facts. Sometimes that's enough. Knowledge graphs add the layer of schema and rules to let you do more interesting things, to find things your graph doesn't know, is not stored in there. Ontologies give us the blueprints. Taxonomies are certainly part of the knowledge graph. You could have more than one taxonomy within your graph, and depending on your domain, well, the taxonomy might be the whole knowledge graph. It really depends on the nature of the subject matter. For search enhancement, the way we've been using it largely is to search for that inferred data, the data that's not stored after rules have been applied. So finding that Andrew was someone with blue eyes. Then for managing taxonomies, keeping them connected to other information in our knowledge graph to serve facets. So when you retrieve parts of knowledge graph, you don't have to retrieve all the knowledge. You can just retrieve the taxonomies you need. And GraphQL and Sparkle is our way to get the knowledge back out, to ask questions of our knowledge. That's what we consider knowledge to be there for, is to ask questions of. And how you would ask questions of it, the questions are also your use cases for the knowledge. So that's a design consideration. Anyway, I'm stopping there, so thank you.